As you might see from the video footage, the tower has been raised.
All stations, this is ONP.
With all stations go, we are now go for fitting procedures.
Can you open the ground fill valve, over?
All stations fitting has started, we see mass increasing. There is currently no indication of a malfunction in the rocket itself. We are go for troubleshooting the problem and attempting again if possible.
It's gonna take a while before the... Whoa, 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 whoa.
Oh, let's go, thank you very much. 5, 4, 3, 2, 1.
There is a student rocketry society in Delft. They've existed for about 22 odd years now, and they treat all manners of amateur rocketry. You can gain experience with propulsion or with recovery or structures or any type of aspect in rocketry. My name is Roderick, and in the Stratos IV project I worked on the propulsion system as well as the ground systems and launch tower. So there, was founded in 2001 by a small group of rocket enthusiast students here at Delft University of Technology. And in the early years, basic research into rocketry was started, and that led all the way up to the first flagship project, which is really the gem of the society, Stratos I. Stratos I launched from Kiruna, Sweden in 2009 and was DARE's first attempt to break the European altitude record, which it successfully set. So after Stratos I, the students of DARE, they were like, well, bigger is better. So then they worked on Stratos II. This time it employed a new technology, hybrid propulsion, which allowed DARE to go hopefully higher than any other rocketry team had gone up until that point. The launch attempt for Stratos II was in 2014, a small base in the south of Spain. However, during the launch attempt, the main valve was shut. They came back just over a year later to try again. And this time they succeeded with Stratos II Plus launching to 21.5 kilometers. A new generation was incoming in there, and so they were like, okay, we need to now work on Stratos III. This was a project that took about 3 years to go from start to finish. During Stratos III, I was a part-time engineer working on the launch tower and launch infrastructure. And in 2018, Stratos III was launched again from the south of Spain. It successfully left the launch tower, but about 20 seconds into flight, it broke apart at about 10 kilometers altitude. This was quite heartbreaking, having been there myself. You see it, crumbling in front of your eyes, a rocket that you've worked very hard to get to the launch pad. This only meant that for Stratos IV, the next flagship project had to fix the problem and try again. And so ultimately the Stratos IV project took about 3 years from start to the launch campaign. Originally it had a 1-year timeline, but in rocket science timelines are a bit more fluid. So a new team came in, including myself as a full-timer. We had the objective to finish off this work and actually have Stratos IV launch. So that meant more engine tests and building all components of the rocket.
3, 2, 1, 0.
My name is Alex, and my role was being the acquisitions manager for the Stratos IV project. Yeah, see, the original goal of Stratos IV actually started out quite ambitious. It was to fix everything that happened during Stratos III, improve upon it, but also to set the new altitude record.
To the finish line of this student space race, 100 kilometers. Now,
being students, we're volunteers, we're not getting paid to do this. So all of the funding for testing, for building things, carrying out something like a launch campaign is all done through our sponsors. So when I joined the project, we were in a tight space. We were still trying at that point, as pre-COVID, to be able to launch at the end of the year, and we had a significant budget gap that needed to be closed. Because you can imagine, these launch sites, all the personnel, facilities, the logistics of getting the rocket there is quite a hefty price for a student team to be able to afford. And that was already difficult enough, and we were struggling at the time. But then the cherry on top was that the pandemic hit, and then everything slowed down.
And we had no longer access to our workspaces, and we had to do whatever we could within the restrictions that were imposed. This included, still building everything and finishing off every last design.
So in that first year, I would say we almost raised nothing in the regard of how difficult it was. We went back to some of the legacy sponsors, explained the situation, also reached out to some new companies. We started getting money in, we started getting more hope along the way as well. And then we carried out things like a very successful crowdfunding campaign that set us up really well for the launch to come.
How you doing?
I know what hair I go.
Most likely.
Yeah, the car is louder than I meant to set, so. Position and open the window blinds. Also switch off electronic devices without flight mode and stow larger devices.
Take this one for me, please. Yeah.
Oh well, okay. It's like Christmas, you know. It's my birthday today.
Yes, Arthur.
Selecting a launch site is actually extremely key to the project because, you know, this isn't just a small rocket that you can go take and launch in your backyard. There's all certain characteristics that we need to evaluate with the different launch sites, but some of the most important ones include the downrange. So since safety is one of the most important things to our society, the downrange is the space that the launch site has aside such that when the rocket comes back down, it's not going to hit anyone, it's not going to hit anything, and that safety can be preserved. So that was one of our fundamental things that we were looking at with the type of rocket we had, the altitude it was going to, and how much downrange space they had available. Now with that, there's a couple other things, like weather. What facilities do they have? Are they compatible with the systems we have on board? We also want to be able to track the rocket properly and also terminate it if necessary, if it was going to veer off course. We looked around the world at all sorts of different launch sites, every corner of the globe. We talked with different space agencies, different sites. So in the end, after renewed discussions, we found that Intisadea in the south of Spain was going to be a perfect opportunity for us. They have top-notch facilities. We have experience with them in the past, which really helped as well. That Stratos III and Stratos II were both launched in there too. They had what we needed. They made us a great deal, that they were really supportive and also sponsoring the project. That was the perfect decision for us to go back to Intisadea for the launch of Stratos IV.
One second. Guys, is everybody already awake here? Yeah. Okay, very good.
Sitting outside. I was, yeah, that's right. Yeah.
So we need to go for 6 weeks to the launch site because there's a lot of prep that needs to be done to carry out something like this safely. So we have the first 2 weeks where we send the most critical members of the team to start general contact with INTA and carry out the most critical tests in advance. Then we have the following 2 weeks of the project where then the rest of the members show up. You know, we assemble the rocket, we carry out more general tests. And then we have the latter phase for 2 weeks where then we're carrying out the launch windows. And those are the opportunities that we're then able to launch. So all in all, we have 3 phases that all span 6 weeks.
Yeah.
I think the first thing I would say is there was no typical day. What you had to do very much depended on what stage in the launch campaign we were at. The days would start very early. We would always be waking up at 6 o'clock.
Speak of the fucking devil.
Once we had breakfast and we did all those things, then we would move to the launch site.
We would drive, or like bike. We also had bikes there. That was pretty funny. We would bike to the base, still when it was all dark out. And we would basically just work on whatever still was left. I'm Jasper Jonk, and I was responsible for the electronic subsystems of the Stratos IV rocket. Electronics is a bit of the glue keeping everything together. So we were involved in a lot of small things for other departments. Also, for example, for recovery, when they had some tests with their wire cutters or any other parachute-related things. We just had to make sure that every little sensor and every little actuation of all different subsystems could work. But yeah, general working day was just the whole day fixing electronics, fixing software, talking things over with the launch site. For the launch site, it's very important that if something goes wrong, we can terminate the flight in such a way that it stays controlled and safe. If we see an anomaly occur at the rocket, we can press a button and make sure that it breaks up. And of course, it had to be thoroughly tested, and this had to be tested with the equipment of the launch site. So therefore, we went in 2 weeks prior to do all these tests and get it verified and working. So there's a little story to how this works. Yeah. Be careful.
I've been here for 5 days at work. 4 of those days has been spent sanding something.
I know that's like a low bar, but it's better than yesterday. I'm Lucia. I was in charge of the propulsion team during the launch campaign, and I was also in charge of all the pad operations. So with regards to the engine, we brought the engine to the launch campaign in parts. So we didn't bring the entire rocket and engine together because it's quite fragile. So during the launch campaign itself, we had to assemble the entire engine, put the fuel grain in, put the nozzle in, and well, we checked out the entire rocket, getting it ready for the launch itself.
So the rocket was about 8.3 meters long. So at the top we have the nose cone, as well as our recovery system, but also the flight computer, because the rocket had to know what to do when during its launch. Then below the nose cone and recovery section, we had the oxidizer tank. And then below this section, we had our engine with nozzle that then allowed the rocket to take off. Opening and closing the ignition valve in 3, 2, 1.
What's the sender doing? The main valve is still open.
The main valve is still open.
Yeah, I know. Don't worry.
So we have this big tank with 174 kilos of nitrous oxide in there, and we have the engine. And you kind of need a plumbing system in between there to get our liquid and gaseous oxidizer into the engine. But you have to make sure there are no leaks in there. So we did a lot of leak testing. We already did that in the Netherlands as well, so multiple days of leak testing. We do leak testing in steps. So first you do 15 bar, which is relatively safe. Then we go to 30 bar, then we go to 60 bar. If you go to 60 bar, you really have to be far away, because then if the tank ruptures or a part shoots off, it's like a bullet shooting at you. And you don't want that to happen.
Did you copy what I just said? Over.
Yes, I copy that there is a tiny leak. Over. Yeah, there is still a tiny leak. That sucks, the smidge. But yeah, it's dropping in the...
I guess one more time.
Nico, how did the leak testing go?
Amazing.
Yeah?
The system is leaking.
Oh,
so,
is that what's supposed to happen?
Well, we did a leak test. We checked for leaks, and indeed there were leaks. So that, in that sense, a pretty good day.
Yeah. How's the heat been?
The heat is really hot, as usual, as expected as well. So a day without any surprise, basically.
Fine. So how's the day?
Yeah, long. Basically spent the entire day leak testing stuff for a third day in a row. So, and hopefully we should be ready for launch, which is really exciting, and it means I don't have to be in the sun pressurizing and depressurizing the system like 60,000 times a day again. So yeah, that's very good.
Nice. So yesterday we had a lot of leaks on the feed system at 15 bar, and then we got some new spare parts at the end of the day. And today those are leak tight. Another leak popped up, but we at least there's an improvement. Some parts are now leak tight.
Nice.
That's a good thing. We're now just cleaning a part to replace the part that is leaking today. So, well, we all got a very good 10 out of it and a lot of frustration because we were out there, I think in the end it was for 5 days.
How was the day?
Yeah, not now, please.
Okay.
I think you got it.
Yeah, it was a little bit of miserable. Point. You really have to get to pad. I'm sorry. I can debrief to him, but we have to get off the pad.
You want
well.
Jasper there?
Yeah, guys, leave at 5:30. That's it.
Sorry.
Yes.
So we're going back to cook.
Nice.
And we are going in an air-conditioned van, or at least by...
The windows are open.
The windows are open. But
Close enough.
with the R purposes.
There were two major types of work that I was doing. The first typical day, and this was very much more in the early days, was setting up all the ground infrastructure. Let's firstly lower the tower. Before we arrived, there was not a lot at the launch pad. The first big step was building up our launch tower. Our launch tower is 16 meters tall, and it also has a lot of ground infrastructure surrounding it. So we would need power, we would need the ground feed systems, we would need the capability to heat our tanks with our infrared lights. All those things had to all be working.
Oh. Well, 1 in 7 chance? Was it 2 in 7 chance?
Yeah, they were very intense, long, tiring working days, but in the end, it was also very fulfilling. We always came back to the camping, could go to a pool.
Like coordinates and everything. It was like 2 kilometers away. Like, shall we start walking faster?
Instagram.
Okay, then I will turn around this one. Niels gets his turn, but everyone is immediately like...
Hey, how's the day?
Long, very tiring.
What'd you do?
We did the leak testing, and now pool break.
Hey.
So that's nice. However, because we are doing a lot more complicated shit this time, we need to transport the rocket all the way to Medan and transport it all the way back for the threshold. So do it again on the 15th, all the way back. It's kind of needed that we do another leak test to see the actual effect of the vibrations.
I need that as motivation. It was an entire roller coaster of emotions. Like when we got back from the base, usually things were good. It was just finished for the day. There was also nothing more we could do. So in the evening, the team were all friends of each other. So in the evenings it was nice, but there was always a little bit this pressure of, okay, we have to fix things. Yeah, I at least experienced quite a lot of pressure. Like, okay, a lot of things were my responsibility because I had the engine, I had the leak testing going well, I was in charge of most of the pad operation, so it was always something, someplace to be, something to do. The moment we walk to the bunker, I'm just sitting there for the next
I think we've been working towards this campaign for, what, like 3 years? Many people putting basically all their free time into getting this thing to work, and then suddenly you're there in Spain for, in my case, 6 weeks. We were there with a group of people with the same mindset, which is really, in that sense, nice. You all want to work towards the same goal. If you do something, you do it for the same goal. There's no other like disturbance or influence. You created like a very nice atmosphere. Like, of course, a lot of work was done. There was a lot of stress involved.
Like everyone else, I wanted to see this thing go across the finish line because I'd ultimately devoted many years now on this project. All the improvements and the implementations of our roll control system, for example, would that work? We were relatively sure, but ultimately the only way to know for certain is to try it out. We bounced out of bed every day to make sure that we could cross this finish line.
Drive to Survive, Season 1. Launch to Thrive. I'm Dion. I was in charge of safety for the Stratos IV launch campaign. So as you might kind of already feel if you're talking about rockets, not the most inherently safe thing in the world, especially with these type of rocket engines. There's a lot of energy in there. You're looking at pressures in there well upwards of 20, 30 times atmospheric pressure here, if not more than that. Tanks that are then double that pressure, temperatures in the engine, upwards of 3,000 degrees. You're dealing with pyrotechnics, I think that speaks for itself. Also, for example, springs that are compressed really tight, high voltage systems. If it goes wrong in a flash. Like, it can go wrong so quickly. And then besides that, of course, people have to handle all this. You have to make sure that if something goes wrong, no one's like in a place where they could get hurt. And then, of course, you have to be there and be like, okay, we have to do this properly. So yeah.
So my name is Nicolas. I'm a propulsion engineer and I was in charge of all the operations happening on the launch pad during the launch campaign. Safety was super important. It is a big aspect, if not one of the core aspects of the mentality in there, is that we have to do things safely. And we even assign people in charge of it, like our safety officers. And their goal is to not have their hands involved in the project, but always to supervise and be able to give a final yes or no whether we could do something if it wasn't safe.
We have a separate team within society called our safety board, which consists of experienced members who have had a lot of experience within there before, learning, like getting the mindset right and how you deal in these like high stress, high risk situations, and also being able to separate yourself. And these people then are basically looking out for the safety of others at tests or pyrotechnic preparation. People do want to push for stuff to go a certain way. Of course, if you're working on it yourself, then you want the thing to succeed and not have to like worry about safety, because you want to just like, push on and do your tests. You're also there for like a really long day, so you don't want people to start making rash decisions because they're tired.
It was also important for all of us to realize that it's not just them to be in charge of safety. We're all responsible, because the more we do, the easier it is for them to take care of it. So safety is needed. You need to think twice about what you're going to do and you need to be aware of how your system will behave. You cannot go about something if you just don't know what's going to happen. A few years before, we all finished designing as much as we could all the subsystems of the rockets, all in our different sub-teams. And a lot of testing, a lot of testing to find problems, fix them, and then just iterate. And then around the end, we also did a few dress rehearsals.
So yeah, dress rehearsals are there to practice the entire start to finish of a launch attempt.
We did a few practice runs in Delft as well. It was relatively easy to have the rocket nearby, to have the tower nearby, so we couldn't really represent what it would be in Spain, but we did the best we could. We of course had to skip a few steps to keep it feasible in Delft, so we would not fill up the rocket if there was no point, and mostly to check not just if the system worked, but mostly the operations, the procedures, and the communication. Yeah, if it is closed, call Willem to get access. And,
So, this is done, this is good. Focus touch the rocket, yes.
So the first part of launch attempt was to first assemble the rocket, which would take a day on its own. So that would be a final assembly of all the pieces, but also a test. Are we sure that the electronics are working fine? all the batteries charged are these pieces fitting together.
This is our top now.
And that takes a whole day, ultimately. It's not something that you can just do in 20 minutes.
And then the next day, we would go on to transport the rocket to the launch pad itself.
We're going to lift it over, well, lift it slightly. Then once you get to the launch pad, you insert the rocket into the tower. You do all the final prep on the ground.
Putting it together, checking it out, do the valves work, just making sure that every small piece of the rocket is intact and functioning before we would actually go to the bunker and start the countdown and the filling.
So at T=0, the rocket takes off and the engine then burns for 28 seconds. So once the engine burns out, it enters a coasting phase. Once it reaches apogee, the highest part of its flight, the rocket separates into several parts. Then went to the next phase where we would actuate our drone. So that's when you would start to slow down the parts that you want to recover. So for us, it would be the nose cone. And after a certain amount of time, we would then deploy our main parachute, which would slow the nose cone even further. It would splash down in the ocean. And then for the other parts, so our engine and our tank, those didn't have a recovery system, so those would end up also splashing down in the ocean, but at a much greater velocity.
That's great. Sounds good. So we can do a simulation of that for tomorrow. Yeah. Do you already have Nick? Want to talk about
the first dress rehearsal was a slap in the face. The reality was just much more complicated because the terrain was not as easy and flat as in the Netherlands. It was in the middle of nowhere with the sand, with the gravel. We were very, very delayed. We also realized all the small things that could go wrong were going wrong. It was very tough mentally.
It took such a long time to get the rocket from the truck into the rocket cart, into the tower. It was just an entire maneuvering effort and everybody was still getting used to it. So that time took 8 hours.
Oh, okay, you meant to say it. Okay, then so we're gonna slightly move it this way and then we're gonna move it a bit, a couple centimeters forward. So
yeah, well, I don't know how busy you guys are on your side. Could you maybe send one of you to do it? Because I know on this side Roderick is quite busy with the rocket.
All right, you're breaking out a bit, but as far as I understood.
On the pad, we were a few kilometers away in the middle of nowhere from everybody in mission control. At first, it was a bit difficult because you had to talk with walkie-talkies and radios to communicate with them. The reception was not always great, so you had to be quite to the point in the communication.
So the communication, but the way that stuff was communicated, we should definitely also say stuff about that. Yeah.
We had to take a step back, and we improved greatly our operations on the pad. So we changed the procedures, we redistributed the tasks among the team members.
I think every single time we practiced, we got better at it. So it was still a very valuable day, even though it didn't feel like we did that much, but we learned a lot.
There's that general anxiousness or nervousness about what's to come. You know, we hadn't actually attempted a launch before. We had prepared so much, prepared for years. Everyone knows the ins and outs of their system, what they need to do. But then finally being there at the pad, going through that 80-page checklist procedure and thinking about all the things that could go wrong, that was pretty daunting. And all things aside, knowing what had happened during Stratos 3 and knowing how much it had taken to get this far, that added extra pressure onto what we were doing, that we didn't want to waste this opportunity.
Honestly, it's not a qualified position. It's just following orders and looking with a lamp.
Okay, then we'll do it like that.
Yeah, I'm helping here with the less things that I can do, and then
I would then actually
I go back.
Yeah, actually get sleep first. The communicator.
High altitude winds have changed. So far, it seems positive. You copy. Over.
So far it seems positive. Good to hear. Over.
Our first proper attempt was also in part a dress rehearsal.
We had time to train and to improve on the mistakes from the first dress rehearsal, but also at the same time it could become our first launch attempt if we were done in time and were ready for it. So the pressure went a bit up because now we know that stakes were a bit higher, and as we went further we were also uncovering a new unknown zone, let's say, in the procedures where we hadn't been before and where possible problems would lie.
Yes. We're ready to go. Nearly. Just waiting on tension straps. Then we go off to the pad. Long day ahead of us, but in the end it'll be worth it. What are you most worried about? Anything that I touched on the rocket, you know, like it's just, you always have that feeling like you know you did your best to make sure it went well, but you know, you only will know once that thing is in the ocean. It's probably just going to be liftoff and I'm just going to sit there in amazement, and then once it hits the ocean, then the realization will kick in. At that point you'll just be like, what did we actually just do, and did everything go, and yeah.
During any launch attempt, we had several groups of people that had all very distinct responsibilities. We had people in mission control. They had an overarching view of the entire operation, all the states of the valves, making sure the electronics worked, making sure the telemetry worked, all of those things, and that was what mission control ultimately was responsible for. On the launch pad itself, we had the people who would control the rocket up until launch, valve operations, making sure that we can fill it, heat up the tank, etc.
It was very nice to see that we actually fixed a lot of issues and we went much further ahead. On the first day it took us 8 hours, and that improved on the next attempts to 4, then 2, then even 1 hour almost.
But this is Tango Charlie, go ahead, over.
As you might see from the video footage, the tower has been raised, but we cannot confirm yet that we have the correct direction, angle, over.
All right, copy that. Please proceed. That will be further in the checklist anyways. Over.
Knowing that it could become real right now, the pressure and the stakes were high. And with every attempt and with every problem we had, we also realized that we only had so few other attempts left.
Tango Charlie, come in, over.
But this is Tango Charlie, go ahead.
Yeah, I think I confirmed that we have about a bit less than 2 hours of delay right now. Over.
We are gonna go for our no-go meeting with Intel, which means that I won't be able to be reached for a little while. Over.
At a particular point during our launch operations, our launch procedures, we have a go, no-go meeting with INTA.
Okay. Are we all ready for the
I'm ready. I informed them. Stay here.
And it's at that point where we critically assess where this launch attempt is. Are the systems working as we expect them to work? Are there particular delays that we foresee? We'll get into the last point where there's no turning back.
So for the intercom with Arma, is that going on track, or is it already been fixed?
All of these systems have been tested extensively over the last weeks, and we haven't had any issues so far. There's 2.5 hours of procedures left. That is fully nominal, so expecting delays of whichever kind. 10 o'clock will be the very earliest we can launch today.
So which is the decision? Go or no?
I think we have uniformly decided that we are go because we don't want to break down and risk doing tomorrow. I would say those.
So for INTA, once we get to this go, no-go point, and we include that it's a go, quite a few things fall into place. We need to clear the sea space. So that meant sending out a helicopter and informing all the boats that are remaining in this sea space that they need to evacuate. So for this go, no-go, especially with INTA, it also means that they need to start investing a lot more resources into making sure that we can attempt to launch.
Now we are going to activate everything for go ahead.
Yeah.
In case that any of these tests is unsuccessful, we have to stop and it's not possible to use.
Yes,
it's clear.
Completely.
So it's a very critical point both for us because we need to know whether the rocket is in a state to fly, but also for INTA because they now need to inform personnel and other operations that they need to perform their assigned tasks.
Are you guys okay there? How long until you can retreat to the bunker? Over.
Please stand by.
The mass of the rocket is 156.2 kilograms. Can you confirm, over?
No, I'm reading 110, over.
Do you have any ideas on why the difference in mass, over?
The biggest issue was the system associated with the load cell.
It was something we had always tested a lot in Delft, tested on the launch campaign. It had been used in previous missions, we knew it worked. But suddenly it was just giving weird results.
But what is a load cell? Well, it's a fancy name for your bathroom scales. Every single time we would load up this weigh scale, it would indicate a particular weight or particular mass. And every time we would step off, it wouldn't return to zero. It would then be 2 kilos or 4 kilos.
Could you check if the load cell is still doing some oscillating behavior? Oh.
I can confirm the load cell is still performing oscillating behavior, going from -200 to +20 kilograms. Over.
Its purpose is to make sure that we knew how much oxidizer was in the rocket. It's important to know how much is in the rocket because we have our flight simulations, and these simulations were written so that we could accurately predict what the rocket's trajectory was. It meant that the simulation that we then relied on in predicting where the rocket would be, how high it would get, the speeds it would attain, they wouldn't match up. If that didn't match up, then you start getting into a very dangerous territory because you cannot then accurately predict what it will do. So it was vital that we knew how much oxidizer was in the tank.
Our approach was to gather as a group, think, okay, what are the possible sources? What is the most probable one? And try them out one by one.
One thing pops in my head that we could do is if there's still a 8-liter water jug there, we could tie it to the load cell, see if it's correct.
So we are currently attaching an 8-kilogram mass to the load cell. I'll let you know when it is fully hanging, over.
We did various tests, like hanging different weights onto it and verifying it and testing it. And we really didn't know what was happening.
Okay, we have it is hanging, over.
I don't see a significant change in the weight.
And the difficult part with that was also that if we pause our activities, everybody else on the base also had to stop. So we had to communicate with mission control that we had an issue and we would be a little delayed. they had to communicate with INTA and INTA with their personnel. So it was a very big communication loop as well that had an impact on the rest of the entire launch campaign.
It sends into its correct point, and we might be able to measure correctly masses. So if we know that this is 192, and we see that the load cell measures that as well, we can then start dumping part of it out.
Alright, this is OMP. Can you come in? Was the test successful? Over?
Negative. It gets stuck. So we are now trying to think of some way of solving it. Over.
Alright, thank you. Over and out.
We did not manage to solve the problem on the day itself, and we were running quite late. We could not fix the issue in time, so we called off for that day. And for us, we had to then tear down the rocket, because we could not leave it there at night.
Alright, then we will approach with all the Bone Rangers and we'll see what happened, and Roderick can solve the issue, I would say.
Thomas! Thomas! Thomas!
Yeah, seeing the rocket in the tower, especially at night, every time, I think it's something that would never get old. It always kind of takes your breath away. Pulling out the lower umbilical, and then we're going to check to see how tight the URS cable is, because I don't know how tight it is. So you have to be quite careful, because if you then start to rush this breakdown of your systems, you can break something, and then later down the line you'll have to live with those consequences. And then we're going to get cleaned up a bit, but the first priority is to get it out the tower while we have as much light as we can, and then we have those lights. Yeah? Okay. So.
The launch pad is very close to the sea, so leaving the rocket or leaving critical electronics and other subsystems there, it would be in a very humid and very salty environment, which is quite corrosive and could damage some very, very expensive material.
And also, while you're on it, I would say remove all the wires, otherwise they will start rusting over the week.
Take out all the plugs. Yeah. Get all the wires out so that they're just hanging next to the lamps themselves.
Are those studio lights good enough for you?
Yes.
Yeah. How'd today go?
It's been long, especially after yesterday. We did like the entire assembly of the rocket, and we found that it took a lot longer than expected, and some stuff didn't go exactly according to plan. So, but overall, it's been also really productive. I am pretty much crashing now. It's 9 p.m. But it's been a good, but very, very, very long day. Yeah.
On this side, the reception seemed to have gone down in the evening.
Yeah, I also don't expect to have any phone connection anymore, so it's kind of shit. Okay, thanks.
Can everyone listen? So we had to make sure that the rocket was in a safe condition. We had to get it out of the tower, and we had to transport it back to our workshop. Again on my count, 1, 2, 3.
Reaching a launch loop, slow down a bit.
And we're gonna now start rotating left, turning left.
But if it took us a few hours to put it up, it took us a few hours to put it down. So even if we had to call off the day at around 6, 7 in the evening, we would still be on the pad until 2, 3 in the morning. Every attempt that we would decide to call it off meant that there were even more risk on the following ones. It felt good knowing that we were taking the right decisions and we were trying to solve problems. We were realistic. But yeah, we also knew that there would be much more work afterwards, after choosing not to launch.
True.
Yeah, like the water would probably be
probably 1.5.
Between the first attempt and the second attempt, there were about 4 days in between. The biggest issue we faced was fixing this load cell and understanding why it behaved like it behaved. And so we used those 4 days to make sure that we investigate what went wrong and any sort of potential fix.
Okay, guys, settle in. John gonna show us At some point, I remember waking up the day after the dress rehearsal. All of us get together like this cabana. I think there were like 20 people in a house that is not even 10 square meters. We're just sitting there on the table brainstorming what could the problem be, how can we fix this. Everybody had their plan, everybody put their heads together, and yeah, we tried our best at getting it done.
If you start pushing a force in this direction, your load cell starts to bend.
In the end, it came down to our launch angle being significantly lower than the one from the previous rocket, which made that the rocket was more hanging on the tower.
It had a bit too much friction for the load cell, and so we ended up having a solution that allows us to compensate. With all of this in mind, we were sure that once we did start filling, that this would not end up being an issue.
What do you think of it, Daniel?
It's pretty good.
Yeah. Alright, so briefing, relatively short. I've been told that it's now Friday, so that means that tomorrow and the day after it is the weekend.
A successful retrieval is like the chances are extremely much higher with these accuracies. So that's another win for the electronics.
We went to the campaign knowing we had 4 windows. And of course, it's the first attempt. And even though we thought we were really well prepared, some things within the checklists or the procedures took a bit more time than anticipated. Yeah, of course, it's sad, but I think it also motivated us for the next one.
To like stay up late, right? Because then at some point it's going to catch up.
Absolutely.
I'd rather go to sleep if you really. Freedom!
And those 4 days between the first attempt and the second attempt really allowed us to go in running basically with the second attempt.
Hello and welcome to the Stratos IV launch show. I'm Liz, this is Niels, who will be your co-host for today. And we're preparing for launch in a few hours from now. Please follow along with us and we'll take you through all the steps and procedures that we need to still get to launch today.
So on the second launch window, everything was going pretty well. We had a little bit of pressure because the weather would be turning later on in the evening. So the time pressure was like, we had to get moving.
Via Bravo, to please read the elevation while the rocket's going up. Over.
Copy that. 20 degrees, 30 degrees, 40, 50, 60, 70, 73.5 degrees.
Everything went very smoothly. Then came the critical point of testing the load cell again.
Via Bravo, this is via Alpha. Could you please give us a load cell indication? Over.
Copy that. Stand by for 1 second. Current compensated load cell value is 161 kilograms. Over.
Let's go, thank you very much.
With a lot of relief, it worked it worked pretty well, and we were good to continue.
Tango Charlie to Pat. This is to announce that we are at the end of checklist Bravo. Over.
Copy that. We are at the end of checklist Bravo, 55 minutes ahead of schedule. Do you confirm? Over.
I confirm. Over.
When the time came to be ready to fill up the rocket, we left the pad, we went to the bunker, which was close by. And we decided to start filling up. There was a go-no-go meeting, which meant we decided to go for the launch in the evening.
But also a very exciting update you might have heard. We are now starting checklist Delta.
So the rocket is at the moment completely ready for filling. We're going to fill up the tanks, heat up the tanks to pressurize it.
Which brings us to the point where we start to make sure that the engine is ready to be fired. It's a really exciting update. And the countdown timer, as you can see, has also started, so we are good. However,
and a lot of procedures were going very, very well, very, very quick, until we ran into our next issue.
With all stations go, we are now go for filling procedures.
Can you open the ground fuel valve? Over.
Ready on your mark.
Stop.
Holding.
We started filling, and suddenly, out of nowhere, we just start to see stuff dripping off the bottom of the rocket.
Somebody said like, wait, what is that? And we're all like, I don't know what is happening. And well, we very quickly call it off because you don't know what's happening. That's dangerous per definition.
It was weird. It was at first very scary, and we just closed all the valves.
And then afterwards you start discussing, okay, what could it be?
The first reaction really is, okay, is there any way that we can fix this? And from a distance, it was very hard to judge what the problem is, because there are particular issues which you can fix from a distance, and there are others which we cannot. And we quite quickly concluded that this was not a problem that we could fix in the tower, since the entire system, the entire rocket had to be taken offline in order to fix this. No, the bleed valve should be open, right?
It's open. It's probably empty, so this probably has to do with the fact that there was mass inside that has now been removed. All stations, this is Tango Charlie. I would like to hereby announce the final decision of a launch in this window. Due to leaks in the system, we are a no-go for launch today. Tango Charlie out.
Unfortunately, we are a no-go for launch tonight due to the pertaining issue we had with leaks in the system. We do not consider it safe enough to try to continue fixing these today, but we will be coming back in a few days, hopefully with all of these lost issues fully worked out.
See you on Friday.
See you. In the tower?
It's supposed to be between the two, right?
Currently about where the trap is.
Okay, what if the grain is in?
And then the next day, we would open up the rockets and see what had happened.
Apparently something was leaking, and we thought it might be the main valve. So we figured it out the next day by taking the entire system apart again, taking the main valve out of it as well. And then we started checking, okay, if I now open and close it, is it still closed? If I now open and close, is it still closed?
The thing is, due to us having to cycle the valves so many times throughout the day to test it, it just happened to be that it stayed open for like a tiny bit. And this gap was not even a millimeter, but due to the immense pressure difference, you could see it leaking out through the engine.
And we figured out that we could test it, I think 3 or 4 times before there was too much play that it would open again. So during the next launch attempt, we were very conscious about, okay, this is now the limitation that we have and we shouldn't overshoot it because otherwise this problem will reoccur.
Wait, don't touch anything.
That was definitely more of a blow. Like the load cell was a completely new issue, but this was an issue we knew, like it was known within the team that this could happen. Again, we thought we took steps to avoid it, but still then you're at the launch pad, and of course it happens then.
It's annoying, it's sad, like how could I have overlooked this? It used to work, why didn't we detect it before? So I guess one of the lessons we learned is when you're testing something, test it in every single possible condition, because if you don't, it will bite you in the ass.
A lot of things have to come together to launch the rocket. And that's also why I have 4 attempts. You don't go there for like one shot and then you just see, oh, the wind is too high, or we had one problem, or we ran out of time. People started taking it into consideration. Like we're not even filling the rocket yet. And that's when the dangerous stuff happens. What if that happens and we see that this and this happens?
It was at this point where the pressure started building up a lot more, because we were starting to run out of our launch attempts, and there was not a lot of time between this launch attempt and the next one. And so there was also a realization, okay, we don't have the luxury now of nearly a week to fix this problem. We need to fix it tomorrow and get ready to go again.
It was leading up eventually to our last attempt. So there was a lot of pressure and a lot of tiredness in the team because we were working very hard. Every launch attempt starts around 5-6 in the morning, and when you have to call it off and break the rocket and bring it back home, it finishes at 3 in the morning the next day, and you would do 2-3 days in a row like this. We were very tired, very motivated because we knew we were getting closer and the problems were fixable. So we had a lot of confidence about it.
Niels, if you can undo the back thumb, and then Martijn, if you can undo.
We really kept that momentum up, so every single problem that we had encountered the days before, we knew them, we knew to expect them and how to fix them.
I would like Philip, if you can undo the 2 tension straps.
So the second attempt was on a Wednesday, and our third attempt was on a Friday. And that Friday also meant that if we were to decide to launch on a Friday, we would not be able to launch on a Saturday right after. We were still faithful, like, okay, we're gonna launch and we're gonna get there, and it's always a step after the other, we're getting closer. But there was still a fear of, okay, what's the next problem? Like, what's gonna happen next? Something will happen, and you just hope that it's something so tiny you will be able to fix anything. We are very much on the minute. So the final attempt at first went very, very well.
Now, where we started out the week before with an 8-hour ground operation, we had now reduced to 2 hours.
And we were even ahead of the schedule. And that felt amazing. It felt like a huge relief because we just improved so much. Everything and everybody was working amazingly together. And we were getting ahead in our procedures.
At that point, like, we were, again, feeling very good. We were like, okay, we asked ourselves what could possibly go wrong.
With all stations go, 10 hours remaining in the window, we are now go for fitting procedures.
So, as we were approaching once again the point where we would fill up the rocket, we were, of course, there was a little fear about, is the main valve going to be leaking again?
All stations fitting has started, we see mass increasing.
I was at the bunker, so I was in front of the live video feeds. The people giving the call-outs for filling the rocket were next to me. And filling is the most tense time. It just takes a long time, and you're basically putting the rocket at risk, if it makes sense.
The crew was in the bunker, we have a view on everything. We were filling it up and we were seeing a bit of ice starting to grow on the rocket. It was expected, it was fine.
Well, we had thought we had fixed the main valve and we ended up being right. So the main valve, it did what it was supposed to when we started adding oxidizer into our system.
I would say it's gonna take a while before the... Whoa, whoa, whoa.
Close front tail valve, close valve.
The ground fuel valve is closed, over.
We decided once again to very quickly cut off everything, but even before that happened, the quick disconnect just jumped off the rocket, and yeah, there was even more smoke.
We didn't actuate it, but the filling arm retracted, so we were like, what happened? What is this?
We saw the quick disconnect coming off the rocket, and I was looking at Jasper Jan. I was like, did you press the disconnect button? And he looked at me, he's like, did you press the disconnect? Like, we looked at each other completely confused. And at that point, seconds felt so long.
So we were so in focus and into our tasks that our first reaction was actually just follow procedures, cut off everything, make the system safe, then think. First do, then think. And once it was safe, you actually felt the reaction of the bunker being like, whoa, like what happened? Like this was weird. We had never seen this. It was just not possible. Like it should not have happened. And it was very scary because now we were realizing, oh, that's a big problem. And maybe we will just not launch.
System. As you guys see, when it disconnected, but it came straight out of the engine bay, indicating there are leaks inside the engine bay.
But they said they didn't activate the quick disconnect.
No, they did not activate, so that's a double problem.
All stations, this is ONP. We will now pose a hold on the clock at T-1 hour and 36 minutes due to an issue when filling the rocket. Over.
Our entire rocket, mostly composed of parts we've designed and built ourselves, but there are certain components that you just buy because you want to know that for certainty that it works. And one of those components is the quick disconnect.
The quick disconnect is a cable that you connect to the rocket to fill it up with the oxidizer. And it's kind of like fueling the car at the pump station. With the rocket, it's quite similar, except that when you fill it up, it is rather unsafe to be around. So the quick disconnect is a special type of connection that you can control from a distance. And once the rocket is full, you can just ask to disconnect it and it will move away.
Can you open the quick disconnect? Over.
Opening the quick disconnect. 3.
It was tested a lot in Delft. We had done many tests with our propulsion system and all our feed system.
Alright, the first test was successful. Let's do 4 others in a row. Over.
It was a special valve that was also used in previous missions, in Stratos III, in Stratos II. So it was even more of a surprise to see it fail right now.
So this was the equivalent of, again, if you're refueling your car, that the pump you are holding all of a sudden just jumps out of the car.
If the quick disconnect is out, it's not like, oh, you can just press a button and put it back in. No.
We had to save the system, get it back into a safe state, get the nitrous out, go back over there, see what happened.
It was quite difficult because we only had a view from the cameras and we just saw that everything looked a bit frozen and it was smoking. So there was little we could know about it. And we started discussion with mission control. What can we do? And what do we still have the time to do? Because the issue was not just that there was a problem, is that there was little time to fix it.
5, this is Tango Charlie. Can you please give me an overview of the state of the system? Over.
Something failed on the tank valve side or something failed on the quick disconnect side.
A small leak started in the quick disconnect, after which it got blown out of the rocket. There is currently no indication of a malfunction in the rocket itself. So as of now, we are go for troubleshooting the problem and attempting again if possible.
We concluded in the end that there was a more simple explanation and that the quick disconnect wasn't really seated properly. We went back a couple of steps, reset the system, thinking, okay, this was a one-off.
Fire, disclose the ground fuel valve.
But then it happened again. And that is when it really started to dawn on people that we might not be able to actually launch.
So we were on the Friday, and it was very close to the final call of the day, asking whether we would go into the night or whether we would take on the next day.
We could only use it if we stopped on time, and that means that they can call off the helicopter, that they can tell particular people to go home.
We were just in time to call off the day, and we decided to go on to the next day, which would leave us enough hours to hopefully fix the problem, and then on a Saturday, try once again for a final launch.
And that's when we started to try to figure out what went wrong, how to fix it, and that was a very long day. That was a very long day.
We were very annoyed. It was just another problem coming up our way. We had already done so much. We were 2.5 years into the project. We were weeks into the launch campaign, extremely tired from all the days one after the other. But it was a very good group mentality. Like, we were all still believing that we could fix this in a way or another.
I felt quite anxious, to be honest, with everything that was happening, because that sure, we've been working on the project for a while, but we were working on different things. The rest of us didn't have extensive technical knowledge to be able to help. So there was kind of a feeling of helplessness there too.
The priority is to get the rocket out of the tower and onto the transport truck. This, I'm basically going to need to trust each and every one of you to make sure that we don't skip anything. I really want to do this fast, but I also need to do this proper, because making a mistake now would be double shit. What that basically means is that everyone, if you are going to do something, really have a look, make sure that no cables are caught, make sure that something isn't loose.
Having worked with the live stream and everything, and just maintaining contact with all the DARE members back home, I knew that there were a bunch of people back in Delft, or even around the world, working, or DARE alumni that were invested in this project and were watching and following every single update. Some of them also had great experience from the previous projects that could help us in this moment. I created a channel and threw everyone in there from our side. It was like all these people, even from years prior, some of them now working, or that they haven't been in DARE for 10 years, that they were staying up late into their night when they had work the next day, that they were putting everything aside to be able to help us because they knew what it felt like, and they really wanted us to succeed too. And seeing that help that was offered to us, just a great feeling to have too, that it was not just us that was in this.
We all together made a plan to find out what would be the most probable cause of the problem, figure out what it is, how can we solve it, can we walk around it. In the meantime, the other people that were quite critical and that were quite sleep deprived went quickly get a few hours of sleep and be ready for the next day because we would need them.
Where we need to physically move the wheel up.
So the next day on Saturday we started early again. We had a lot of hours to spare and we just tested the piece. We thought we found the problem, now we had to find a solution.
The issue was the fact that the seal broke down when it cooled down too much.
And we tried many techniques to fill it up, maybe in steps.
It was okay, we fill for a bit of time, we let it rest. We fill for a bit of time, we let it rest.
At some point we decided, okay, it's time to get back into the actual procedures and try again to launch. We got again to the point where we had to fill it up.
What is it, Charlie? Go ahead.
This is to inform you that you are go for filling and heating procedures. Over.
Go ahead.
We're now going to start filling the rockets and we will announce the weight every 5 minutes.
Can you open the ground fill valve? Over.
Opening in the ground fill valve.
You see mass increasing.
But yeah, unfortunately none of the solutions worked and it just kept on breaking off and it kept on not filling the rockets.
on the rocket.
On the outside.
It turns from the outside. Okay, confirm nobody is going to the pad right now?
All the people that were on the pad, we were all safe in the bunker. We had a big discussion. All the persons that were there on the spot were people that had the most experience to also solve the problem and that knew if it would work. And we just discussed. At the same time to realize what were our feelings and be able to put apart the emotional decisions and the rational decisions. Because it was extremely tense. And we had a discussion. What do we do? Do we call it off? Is it safe enough?
Going into this last day was always going to be a bit tricky because you hear stuff from mission control that they want to have this just keep pushing no matter what. But if people want to go no matter what, then people will start cutting corners. And then I brought up the point regarding we don't know if this will happen, when this will happen with the quick disconnect.
And then Dion was like, okay, but what would happen? Like now we're only filling very small amounts. Say we got all that mass in there and the filling arm would shoot out then. You didn't have it in control and it was quite a dangerous situation.
So I don't think this is a predictable enough state for us to do anything with. I'm not sure if we can solve this on time.
It feels like that this one no cancels the whole project. But I think considering the safety, it was just not a sensible thing to continue.
You get to a point where you just get stuck and you have to do the same thing, and we will just end up getting the same result. Like something magical, frankly, would have to happen, and you have to then balance it off because everyone is sleep deprived, everyone is running on fumes, and that then ultimately just becomes dangerous. Within there, safety is at the heart of everything we do. If we decide that it's not safe to do so or it puts people's lives at risk, that's when we do stop.
We did a round, and then we just took on a decision, and then we had to call mission control to tell them the news that we were just not going to do it. So the aftermath was it sucked. It really hurt. There was a lot of tears, a lot of people needing a break, and after just weeks and weeks of trying, it just felt like the first time we had a break, and we were just realizing like it's over.
Everybody was just very sad that it didn't happen. You make a rocket. Sole purpose is to fly, and it does everything. Goes through all the checks, all the lists, but it doesn't fly. Yeah, no one wants that, of course. So
I had accepted that maybe something would go wrong during the flight. In not being able to launch, I at least personally, I never thought that we won't launch. Like having to decide to pull the plug on a project that you've worked on, blood, sweat, and tears for 2.5 years, it felt like I was dropped from 100 kilometers to the floor.
It feels rough, because everyone has worked so hard for this, and fundamentally, as safety, your role is for people to be safe. But still, of course, it does feel disappointing that the thing that you say is in the end the reason that the rocket didn't launch. I mean, I stand by my decision, and I stand by what I said. But, it doesn't mean that it suddenly feels great.
It was just, you had all this build-up over all these weeks, and suddenly it's done. The decision is made, there's nothing you can do. So at that point, you just feel like a failure. Like the quick disconnect was my responsibility, the main valve as well, whatever I had worked for the past 2.5 years, done.
And we wanted to tell you guys first, of course, before we're shooting out. So the people at the pad were not able to work out a solution that was predictable and safe. Safety is always the thing we go on about. That's also one of our core principles. So if we cannot do that, then management discussed it. And this time it's a no-go.
Okay, so are there any questions? It's shitty that we couldn't have like realized this sooner, of course. Besides that, the greatest accomplishments, all the things that we did solve together, because all the other things that went wrong could have basically were on the same margin due to this. But we have been able to solve so much of it that I think that is the thing to reflect on and be really proud of. Can you elaborate on this?
Actually, Rolf, can you check Alex's message? He thinks it's really important that you look over it.
Yeah, sorry for dropping out for a while. I was just reading it, and I'll make some small adjustments.
Yeah, so immediately after relaying the news to the rest of the team, we had to get the word out. So there were all sorts of stakeholders involved. Of course, there's friends and family, but also these sponsors that had invested so much in us. That's, of course, something that you're nervous about, to have to go tell them that, of course, we don't think that it was all for nothing or that it was a waste, but, we didn't know what the responses were going to be. We actually had some great notes come in from members of the industry saying that this is the way that things are, and that there's that one part that was always working and then on the final moment it doesn't work. Maybe other teams would have felt go fever and wanted to keep going until the last moment. It was just great to see how supportive we were, and that really gave us the confidence that we made the right call.
In the days after the decision, we first took time to collect ourselves. We broke the rocket apart, we packed it all up, and then it was ready to ship back to Delft. And then slowly people were also brought back to the airport so they could also go home.
So directly after the launch campaign, everything had to settle in for a little bit. Like after some time, I got to realize I built an entire rocket. How many people can say that? Like I had this 8-meter rocket on a pad in the tower, and it was such an achievement.
The feeling of actually being so motivated to work together to achieve a goal was definitely something way better than I expected. So yeah, in the end, we left with the rocket, but I don't think there's much else. Like it was definitely not for lack of trying. We tried really hard. We would not have been there if we weren't confident that it was going to fly.
We faced challenges that not many people face, and the problems we could fix in that moment in time, we managed to fix. We fixed it quickly. So I'm incredibly proud of the project as a whole, and I think we still achieved everything that we wanted to achieve, except for that cherry on top of it actually leaving the tower.
Is that fucking Top Gun music?
How they would how they would flow.
Okay. Secondly, roughly how many people will be at base and how many won't?
I expect basically everybody to be at base minus at most 2 or so.
Because that answers my second question, where exactly.
What do you think of the dinner?
It's pretty good.
Yeah. What do you think of people putting cheese on the dinner?
No!
I mean, I'm gonna take him to the Hague for crimes against humanity, but you know, I'll do that after October.
Cool.
Hello! I'm asking if we are continuing procedures or if there is now an entire photo shoot. Over.
Live, this is Ofcom. I can still hear you, but very distorted. Over.
You can't blame him. He's like from rural Illinois.
Chicago.
Yeah, basically the same. They just have corn where he lives. It's fine. We love him.
Oh my god.
Despite his boomer tendencies.